Hello, welcome to this second episode of MMC Sheds Light on Optical Fiber. Today's topic is how to choose an optical fiber. In the first video, we identified various types of optical fibers: OM3, OM4, and OS2. Today we'll learn how to choose an optical fiber depending on its application. To do so, two questions need to be answered. The first one is, what's the maximum transmission length for my optical fiber? And the second question is, what application area will the fiber optic support? If I can answer these two questions, then I can choose the fiber optics type I need. Why? Because different maximal transmission lengths exist per optical fiber and protocols. On this slide, we can see the various protocols in gigabytes with their associated maximum lengths. For example, 1000LX shows that the maximum transmission length for OM3 is 1000 meters. For OS2 fiber, it's 5000 meters. What is LX protocol? L stands for long wavelength. So we're dealing here with wavelengths of 1300 or 1310 nanometers, because the LX corresponds to the second transmission window mentioned in the first video. This second transmission window is for multimode and single-mode fiber optics. In an SX protocol, where S means short wavelength, we're dealing with the small wavelength at 850 nanometers, which now corresponds to the first transmission window exclusively for the multimode fiber optics. That's why for an LX protocol there are single and multimode values. With SX protocol, we only have multimode values. Here's another example. On a 10 gigabytes network, the 10 gigabytes SX, the maximum length of the OM3 fiber is 300 meters. The maximum length for OM4 fiber is 550 meters. So to transmit 10 gigabytes on 400 meters, then I have no choice but to use an OM4 fiber. Why? Because with OM3 fiber we're limited to 300 meters. That's why it's important to know your network protocol and its maximum transmission length in order to choose the correct optical fiber. Once I know the type of optical fiber, then I determine the type of fiber cable. The type of fiber cable, namely its construction and outer jacket, will depend on its immediate outdoor environment. For an indoor cable, an LSEH jacket is preferred that's low smoke, zero halogen, with a low smoke output and no toxicity. We'll also choose CPR levels that are best suited, such as the DCA or even the CCA. Multimedia Connect offers a range of indoor fiber cables that includes the B2CA class. If I'm outdoors, my fiber cable must correspond to criteria such as UV or water resistance in case of bad weather. So I will choose a cable with a polyethylene jacket, knowing that polyethylene is strictly forbidden for indoor installations. The EN 50174 standard limits the penetration depth at 1.5 meters for polyethylene cables inside a building. So polyethylene cables are best for outside, and if I'm in an environment where rodents could come, such as rats and other small animals, an armored cable with steel insert is preferable, knowing that the armored cable can also be buried due to its high resistance to crushing. For all sensitive environments, such as petrochemical sites or tunnels, it's better to choose a fire-resistant optical fiber, namely an optical fiber compliant with the fire resistance standard for fiber cables, the XBC 93539 standard. Multimedia Connect offers a fiber cable called FOFIRE that has a 90 minutes resistance to fire, allowing data transmission during those 90 minutes. That's it for the second video of MMC Sheds Light on Optical Fiber about how to choose an optical fiber. Don't miss our third video where we'll discuss the different types of single-mode optical fibers. Thanks, and see you soon.